Yes, Shunu.
Is that clear for you, Michael?
Yeah.
So, can you tell me what is the time complexity of add here? Add method.
Add is constant, right? Will be adding to the enqueue stack.
Yeah. So, what is the time complexity of delete?
That is also constant as it will from the stack.
Yeah. So, generally, what will happen?
Um,
Yeah. So, this is
yeah.
confusing part. So, delete definitely constant. Why? Because each element in worst case can be visited twice, right? Yes or no? One time you will insert, other time you will delete. Yes or no? One time you will insert from NQ to DQ, other time you will just delete it, right?
But inserting is happening, right?
Mm. Happening.
So, but inserting might be any number of
Are you
elements, right?
doing it for each delete or once in a while?
When
That is
the
once
stack
in a while.
is not empty, then we will
Yeah,
is
we will
empty.
blindly take the value from the top, right? And whatever value you are taking from the top, which is being visited second time, right? Yes or no? First time you will insert, second time you will delete. Yes or no?
Correct.
Blindly. So what I'm trying to say is whatever operation you are trying to do on DQ, so it is not continuous, right? So there are two ways to understand. In simple, if you want to speak about it, each time you are not doing it, so once in a while, so on an average, you can say it as a constant. That is one way to say. The other way is whatever elements you so when do you say it is linear? When do you say it is linear?
It travels to the
When
whole.
for
For
each
each
operation
delete,
we
for
are doing
each
it.
delete, if it is taking n operations, then it is going to be linear, right? But in this case, for the first delete only, it will take n. From the second delete onwards, it is going to be constant, right?
Correct.
So once in a while, right, you can ignore this. So it's not continuous. Now, for example, you have 1 million elements, and assume that you have added half a
Not
million.
like won't happen, Rich. At least once we will get right.
Yeah, so it happens only it happens once in a while. Sorry, Maitri. What is your question?
So initially the DQ stack will be empty.
Yeah.
So NQ we keep whenever we get request for add, we only update NQ stack, right? We are
Yes.
not touching DQ.
Yes. Yes.
Whenever we get delete, we will verify if DQ is empty.
Mm.
That's when we'll copy all the elements of the stack to DQ stack and pick the first one.
Correct.
So for further deletions, we can leverage the DQ stack.
Yes.
But for at least whenever our input has at least one delete operation, it's always sure that we will do that copy, right? So even if it's a once in a
I
while,
got it.
big
I
of
got it.
n is
So
for
it
sure.
means, yeah, you are saying one add, one delete, one add, one delete, right? So you add one, then delete one, add and delete, right? Even in that case, also, do you think it is linear?
No,
So it always be constant, right? What is your doubt? Do you think delete is linear or constant?
no, I so in our operations, not just adding, right? Delete also happens, right? And whenever we perform delete, at least for the initial delete operation, we do a big of an operation, no?
Yes, yes. So that
Uh,
happens
so
once in a while,
potentially
right?
it's once in a while. It's not uh, once in a while, right? It's for sure for the first deletion, we should go for big of one, right?
Yeah, that's what I'm saying. Yeah, that's what I'm saying. Let's say you have 1 million elements, and let's say you have added 1 lakh elements, then you try to do 2 lakh, 1 lakh deletions. Okay, so this is 1 lakh additions, then you did 1 lakh deletions. Then what will happen for the first deletion? It is going to be linear, and remaining 90,999 times it is going to be constant, right?
Hmm. Yeah.
Even if you add another 3 lakh elements here, still this is going to be constant only, right, for these elements.
Yes.
So then after these 1 lakh elements were deleted, and if you want to delete one more element, then again you copy these 3 lakh elements,
Right.
right? So so it means for 3 lakh elements, one time it took linear, and remaining all the time it is going to take constant, right?
Okay.
So what I'm trying to say is, once in a while it happens, right? So you copy only once, and for most of the cases which is going to be constant. So that's why on an average you can say delete operation also constant. Is that clear, Kalyan? Ajay?
If it happens for every element, then only we consider it as linear, is what you're saying, right?
Yeah, that is what, right? So when do you say the more impact? So if it is happening for each element, if it is taking n times, then you can consider it as n. But if there are 1 crore elements, and for one element it is taking n, for remaining elements if it is taking constant means, so you consider this one, right?
Yes, got it. Thank you.
Maithili, is that clear? You are not convinced.
Yeah. No, no, now I'm convinced. Like, because it's not for every
Yeah,
operation, we can ignore that linear.
yeah,
We will weightage more to the one. We'll give more weightage to this is what you're saying, right?
correct. Yeah, that's what. Okay, so let's do that. So we want to design a queue using stack. Okay, so what is our thought? We just need to take a stack of integers. So one is n cube, and a stack of integers. Another is d cube. Okay, so let's take that. Stack, and similarly, yeah, it's your choice which one you want to copy. Sometimes you, okay, so this is new stack. Okay, so what is our job? So when you want to push, just add. Then when you want to pop, first check if my dq is empty. Then your job is what? You copy all the elements as long as your nq is not empty. Take all these elements and add to this dq. Add of nq dot pop. That's it. And you first element will be on the top, so that you can just remove dq dot pop. Then what do you mean by peak? So pq, same thing, right? So peak also same thing, right? So it means the first element. Peak means first element. So if the dq is empty, copy from nq, and then finally return dq dot peak.
So you need to push that element. The method is dot push, right? Not add.
Okay, both. I think both will work. I think
Oh,
we have
okay.
add also. It's fine. Okay. Similarly here, right? So even peak also should return the first element, right? So first element is always present in dq. So you just do dq dot peak, and yeah. So when do you say it is empty? So you need to check both. If nq is empty and dq is empty, then it is empty. Otherwise, it's not empty. I think you can beautify this code. For now, I just written randomly. So this is how it is. What's happening? Okay, let me log in. I forgot the
Shreyans,
password.
like yesterday you mentioned, right? Like if we go with iterator, it will give us first item, even first tag. So using
Yeah,
iterator, can we use index concept and solve this with one stack? Just
yeah, but
understand.
that is more. Yeah, I think they don't accept it. If you want to iterate, yeah, it will work. I get that. So it will work, but I think they don't accept it. I forgot the password. Just a minute. Uh, I think it is in.
This is what happens, Shenu, if you have multiple accounts with lead code.
No, I have only one account. The problem is this account is not linked to our meeting invite. So I will add this so
That's
that.
what I'm saying. Like you solve the same problem through multiple accounts to practice and gain more points.
No, 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 no. I have one account only, one premium account, right?
Okay.
Okay, data won't be for PDF. Excuse me. Actually, I have updated the email, then it's not working. We lost the code. But you can able to write it, right? So let me do it in. Let's solve other problem. I think this code we missed it because I didn't log in right. I think we could have lose the code. It won't maintain. Oh, it's there. Okay. Oh, it's already here also. Okay. Yeah, that's it. Okay, so let's move on. Can you implement this? So we wanted to design a circular queue. So what do you mean by circular queue? The last one will connect with the front one. So let me explain it. Okay, so let me explain. So we want to design a circular queue. So you will have three operations, four operations. One is NQ, so which will insert, DQ, which will delete the first element, NQ means it will add the element at last, friend means it will return the friend, rare means it will return the last. So, and he is also giving size of k. So he will be giving the queue size. So this is how the queue size look like. So let's say k equal 3. Can you see the screen? Again the problem, yeah. Something was happened to my system today. It was bad day. Sorry for that. Just a second.